Sample problem number 2. 3-point charges are located at the corners of an equilateral triangle as shown. Calculate the resultant force on the 7 microcoulomb charge. So before answering this problem, you have to take note, just like what we did sa sample problem number 1, that the resultant force must be in terms of a unit vectors. Like for example, in a two-dimensional system, so the force is in terms of f1x I hat plus f1y j hat. So the I hat and j hat na unit vectors. So now, first assign the 2 microcoulomb charge as your Q1, then assign 7 microcoulomb charge as your Q2, assign also the negative 4 microcoulomb as your Q3. So the charge in question is the positive 7 microcoulomb charge. So just like what I said to sample problem number 1, so you need to draw an FBD first. Okay, so what is an FBD? That is a free body diagram. So where we put all the forces on the charge in question. Okay, so 7 microcoulomb charge, we can represent this one as a point, so that one, and then here we can see that the 2 microcoulomb charge exert a repulsive force to Q2, or the 7 microcoulomb charge. So meaning that the force exerted by the is in that direction. Okay, so this is the force exerted by the 2 microcoulomb charge. So one. The next, remember also that the force exerted by the 2 microcoulomb charge must be in the same line of interaction, as you can see here. So although dili siya straight line, but just like what I said, dapat na siya sa same line of interaction. Now for Q3, or the negative 4 microcoulomb, so it is actually attractive. So meaning that the force exerted by the negative microcoulomb charge is going in this direction. So this is the force exerted by the negative 4 microcoulomb charge. So here sa free body diagram, so we just have to put this one, the force exerted by the 2 microcoulomb, and this is the force exerted by the negative 4 microcoulomb. Okay, now just like what we did sa sample problem number 1, so we have to define some axis where y is the vertical axis and the x is the horizontal axis. Okay, so to find the net force by using the superposition principle on the 7 microcoulomb charge, so we just have to sum all of them. So the force, or the net force sa imuhang 7 microcoulomb is the sum of the force exerted by the 2 microcoulomb plus the force exerted by the negative 4 microcoulomb. Okay, so we have to solve them individually. So first, ato sa tani force exerted by the 2 microcoulomb charge. So here sa just like sa atong note, niingon ta nga atong express atong force as unit vectors. So we have here F 2 microcoulomb x component I hat plus the F 2 microcoulomb the y component in j hat direction. So there's no k hat because we are in 2-dimensional plane lang. Okay, so we have only 2 unit vectors here representing the x and y direction. So as you can see here, sa imong 2 microcoulomb, the force, so we have to make a coordinate system where atong origin is si 7 microcoulomb. Tanaw na to kung unsa ang angle ni 2 microcoulomb. Okay, so this is the angle from the positive x-axis, mao na ang angle ni 2 microcoulomb. So tanaw na to sa atong configuration, we can see that that is actually equal to 60 degrees. Okay, because they are in the same line of interaction, so this angle is actually equal to 60 degrees. But how about the force exerted by the negative 4 microcoulomb? So unsa man ay ang angle? So ang angle is, okay, since this is 60 degrees, okay, this is 60 degrees, diba? Because this is equilateral triangle, so meaning all angles are equal. So since our 7 microcoulomb is our origin in our coordinate system, so makita nato nga this one sa yung geometry that this angle is equal to this angle. So kung nagforma siya og z nga pinabaliktad, that is actually equal. So I don't know unsay tawag ani nga angle, but that is actually they are equal according to your geometry, di ba? So meaning that the negative 4 microcoulomb also has 60 degrees nga angle. Okay? So balik ta diri. So the force exerted by the 2 microcoulomb, so we have here force exerted 2 microcoulomb is equal to, so the magnitude of force exerted by the 2 microcoulomb, then we have here cosine theta, then I hat plus f 2 microcoulomb magnitude sine theta, then j hat. Diba? So balik ta. So sine theta. So here, ang imong cosine theta, so the angle sa imong 2 microcoulomb is 60 degrees. So we have to but since the magnitude of the force exerted by the 2 microcoulomb is constant to both terms, so we can just put it outside. Okay, so because that is constant, then multiply with cosine 60 degrees I hat plus sine 60 degrees. Okay, so wala. Sine 60 degrees j hat. Okay, so that wala siya. So next, find the magnitude first. So we have to find the magnitude para ato na siyang i-simplify. So Coulomb's law states that we have K Q1 Q2 over R12 squared. Then we have here cosine of 60 is actually equal to, what is cosine of 60? 60 degrees is 0.5. So that is 1/2. So 0.5 I hat plus the sine of your 60 degrees is equal to 0.86, or that is equal to square root of 3 over 2 j hat. Okay, so to find the magnitude, so simplify. So your K is Coulomb's constant equal to 9 times 10 raised to 9. Then your Q1 is equal to 2 microcoulomb, or that is 2 times 10 to the negative 6 coulomb. So we have to stick with SI unit. Then your Q2 is 7 microcoulomb, same lang gihapon, that is equal to 7 times 10 to the negative 6 coulomb. then divided by the distance. So the distance between Q1 and Q2 is equal to 0.50 again, because all of the sides excuse me, of an equilateral triangle are equal. So meaning this side is 0.50, this side is also 0.50, and same also with this side. So di na to siya i-convert because because meter is already an SI unit. So 0.50 meter squared, then we have the angle. So we have times 0.5 I hat. So ako na siyang ibutang dali, times 0.5 I hat plus square root of 3 over 2 j hat. Okay? So muna siya. So simplifying for the magnitude of your force exerted by the 2 microcoulomb. So we have here 9 times 10 raised to 9. Then multiply with 2 times 10 to the negative 6. And then multiply again this one to 7 times 10 to the negative 6 divided by 0.50 squared. So that is 0.504 Newton. So with the direction of, say, I hat, I mean this is positive. Okay, so I can just, okay, so that is equal to 0.5 I hat plus square root of 3 over 2 j hat. So simplifying, so we have to multiply this 0.504 to 0.5 and also with the j hat. So 0.504 times 0.5 is equal to 0.252, then that is equal to Newton I hat plus this one 0.504 times square root of 3 over 2, then that is equal to 0.436 Newton approximately j hat. Okay, so now that is the force vector exerted by the 2 microcoulomb charge on the positive 7 microcoulomb charge. Now how about for the force exerted by the negative 4 microcoulomb charge? So just like what we did, so we can express this one as unit vectors. So F negative 4 microcoulomb, the magnitude, magnitude, I know this is not the magnitude, so can I erase this one? Erase. So this is one is the x component I hat plus the y component of the force j hat. Then we can express this one x and y using cosine theta and sine theta. But remember, as you can see here, sa atong negative 4 microcoulomb, the 60 degrees is is rotating clockwise. Okay, so here, if mag-rotate siya counterclockwise, atong angle is measured or equal to negative 60 degrees. Okay, so kung counterclockwise, positive imong theta, positive. But kung clockwise, negative imong theta. So here, in order to stick with cosine theta as your x and sine theta as your y, so we have to stick with this convention. But if ever nga di mo ganan ana, so you can use also the SOHCAHTOA. So here, the side that is opposite to the angle is your y and the adjacent is your x. So same lang gyapon siya. So but we have to stick with our convention nga clockwise is negative. So we will use negative 60 degrees for our angle, di ba? So here, simplifying, so we have force by the negative 4 microcoulomb, then cosine theta, or the cosine of negative 60 degrees. Okay, so that's it. Negative 60 degrees I hat plus the force, again the magnitude, negative, then sine of negative 60 degrees j hat. Okay, so we have that one. So again, since magnitude is common to both terms, so we can put it outside the expression. So we have force of the negative 4 microcoulomb, but what is the negative cosine of negative 60? So since cosine is, as you recall sa inyuhang uh, trigonometric function, that if we get a cosine of a negative angle, that is actually equal to cosine lang gihapon, meaning cosine 60 is equal to cosine of 60 degrees. Okay, so equal naman siya sa based on this trigonometric nga identity. So cosine of negative theta is cosine theta, since this is an even function. Then sine of negative theta, mao ni siyang odd function, so we have the negative sine of theta. Okay, so cosine 60 degrees I hat plus, so erase ni siya, can erase the ano here, so ako lang siya erase. So cosine 60 degrees I hat, then here your sine of negative 60 is equal to negative sine of 60 degrees j hat. Okay, so simplifying, so we have here your force of the negative 4 microcoulomb. So by Coulomb's law, K Q2 Q3, then the distance squared, then cosine 60 is just 1/2 or 0.5 I hat, and then your sine 60 is just equal to square root of 3 over 2 j hat. So now simplifying, we have K as 9 times 10 to the 9, then your Q2 is equal to, how much is your Q2? 7 microcoulomb. So we have 7 times 10 to the negative 6 coulomb, and then your Q3 is negative 4 times 10 to the negative 6 coulomb divided by the distance. So the distance is 0.5 meter squared. Then absolute value, so copy lang sa 0.5 I hat minus square root of 2 over square root of 3 over 2 j hat. So what is now the force exerted by the negative 4 microcoulomb? So we can compute the magnitude first. So 9 times 10 raised to 9 times 7 times 10 to the negative 6 times 4 times 10 to the negative 6. So ako nang give 4 kay because ang positive mawala naman kay absolute value man na siya. So divided by 0.50 square. Okay, so that is equal to 1.008. So we have 1.008 Newton. Then we have 0.5 I hat minus square root of 2 j hat. So we can simplify. So we can distribute 1.008 sa ato ang expression. So that is 1.008 times 0.5 is 0.504 I hat. Next, 1.008 times square root of 3 over 2. So that is equal to 0.873 approximately Newton j hat. Okay, so this is our expression. So now, adding all of those forces, so that we can now get the force exerted by the force exerted on the 7 microcoulomb is equal to, so the force by 2 microcoulomb is this one, so we have 0.252 Newton I hat plus 0.436 Newton J hat. So this is the force exerted by 2 microcoulomb. Then add this one to the force exerted by the negative 4 microcoulombs. This one. So we have 0.504 Newton I hat. So I forgot the Newton here. Minus 0.873 Newton J hat. Okay, so we have to combine like unit vectors. So we have to add 0.252 Newton and 0.436 Newton. So we have 0.252. No. Sorry. We have to combine like unit vectors, diba? So 0.252 plus 0.504. So plus 0.504 is equal to 0.756. So that is your I hat direction. Next is here, i-combine na to ang j hat. So that is minus 0.436 minus 0.873. So that is negative. So we have negative 0.437 Newton J hat. So this is your answer. So mo ni ang force on the 7 microcoulomb. Nya since niingon naman siya nga calculate the resultant force, so meaning ato siyang express, atong answer must be expressed in unit vectors. But if maingon siya find the magnitude and direction, that's the time that you get the inverse tangent function for the angle, and then also the magnitude put kung ano yung magnitude. So katong square root of f1x squared plus f1y squared if given mo magnitude and direction. So meaning asa man ni naka-locate ang atong net force exerted by the 7 microcoulomb. So kung tan-aw nato ato ang force vector sa atong 7 microcoulomb, ang imuhang I hat is positive, but imong j hat must be negative. So meaning that ang iyang net vector or the net force vector is actually located in quadrant 4 because the x component is positive and the y component is negative. So dapat approximately naa siya dapit diri, okay, sa imuhang this is the net. Okay, so this is the net force, okay, sa imuhang 7 microcoulomb. So meaning nagdominate ang force exerted by the negative 4 microcoulomb. So which is okay. So please look at also na kung tan-aw nimo ang exerted by the 2 microcoulomb, they are both positive because because the force is actually in the quadrant 1. So meaning the x and y component must be both positive. Now for the force exerted by the negative 4 microcoulomb, so we have positive nga x component but negative nga y component. So that is because our force by the negative 4 microcoulomb is in quadrant 4. Okay? So that's it. So that is the importance of the angle. So that is why it is very important to take note of the angle, because if marong mo sa angle, then marong na detanan yung answer, yung solution. Okay, so take note of that. So I think that's it. So that's the answer for the sample problem number 2.